Standard quantum mechanics operates on a known contradiction. The continuous Schrödinger equation models the smooth evolution of particles, yet we rely on the probabilistic Born rule and wave function collapse to explain discrete observations. General relativity presents a similar conflict. It defines the universe through smooth, continuous spacetime manifolds, structures that resist integration with a framework built on discrete probabilistic jumps. Within the unified dynamics framework, these smooth fabrics and continuous wave functions are categorized as operational fictions. They are macroscopic statistical averages that obscure a deeper, discrete structural reality. Unified dynamics identifies the absolute foundation of reality as a background-independent network of interlocking tetrahedra, known as K4 simplices. This architecture treats space as an information-theoretic state machine. Every location in the web is a node processing a relentless stream of discrete updates. By mapping the combinatorial limits of this network, we can derive the exact mechanisms for wave collapse, mass, and gravity using zero free parameters. In this model, physical substance is replaced by an algorithmic ledger. What we perceive as matter is the observable result of strict structural constraints in the network. The continuous wave function described in textbooks functions here as a discrete phase optimization routine, moving data through the tetrahedral grid. This diagram shows a single K4 vertex governed by a vertex information capacity limit. A node can only sustain a processing debt of 7/768 of its configuration space before it reaches a saturation threshold. When the local state update density hits this hard ceiling, the node refuses any further incoming data to prevent its internal connectivity from failing. An admissibility operator manages this gate. It is a Heaviside step function that slams shut at the limit, instantly deflecting branching pathways of data away from the overloaded node. This makes wave function collapse a deterministic time lock. The network selects a specific deep time routing branch to prevent state stagnation, regardless of perceived probability. This mechanism provides the physical engine for Widener's small signal truncation hypothesis. It explains why low amplitude branches vanish. They are simply the pathways the network could no longer support. This truncation also explains Barton's environmental nudge. The phase transition he describes is the result of the network reaching that rigid 7768 capacity boundary. By identifying these rigid data throttling limits, unified dynamics removes the need for randomness. The universe follows a strictly deterministic path dictated by the processing capacity of its nodes. Goldstein and Zhang He propose that the wave function is nomological, a timeless law of motion rather than a concrete material field. Unified dynamics defines that law as the recursive, six-part generative grammar of the K4 simplex. It is the rulebook for how data must move through the tetrahedra. This diagram shows a phase vector attempting to traverse a closed loop in the network. Because of the tetrahedral structure, the path is never a simple straight line. Each intersection contains a chiral torsional operator. Because the tetrahedral geometry breaks spatial parity, it applies an irreducible twist to the vector's angle as it passes. This twist creates a permanent geometric phase shift. When the vector completes its circuit, it no longer aligns with its starting position. This prevents destructive interference, trapping the energy in a continuous cycle. Evans' matrix node theory identifies particle formation through interaction thresholds, but unified dynamics proves the specific geometry behind it. The particle is the result of that inescapable geometric mismatch. This localized, trapped standing wave is a simplicial Holonomy circuit. What we measure as mass is simply the frequency of this persistent defect. In this framework, particles are not separate objects. They are geometric traffic jams in the network. Moving to the macroscopic scale, we can observe the collective behavior of millions of interacting nodes. At this scale, spacetime operates as a ledger of network path costs. It tracks the time and resources required to move data from one node to the next. This diagram shows a cluster of Holonomy circuits representing a massive body. Their presence creates a radiating gradient of processing debt, or intense network congestion. We experience this congestion as gravity. As phase execution velocity slows within the debt-heavy zone, traveling data wavefronts bend towards the center of the mass. This identifies the discrete origin of the thermodynamic boundary constraints proposed by Bernardo. Gravity is the macroscopic manifestation of this localized lattice pressure. If this pressure is not relieved, the network faces structural collapse. To survive, the system must shunt data away from congested zones. It accomplishes this through triadic co-boundary transport, an automated routine that moves processing debt across the higher dimensional faces of the tetrahedra. This transport follows a strict asymmetry. Debt expands across 3 faces, a 4/3 multiplier, and then compresses into 2 downstream edges, a 3/2 multiplier. Because the cycle is structurally asymmetric, the state updates cannot be reversed without violating the network's capacity limits. This creates a mandatory one-way flow of data, providing the mechanical engine that drives the universal arrow of time. This theoretical foundation leads to new technological possibilities, such as those hypothesized in the medium-pressure unified dynamics theory, which views the vacuum as a dynamic medium C. If the vacuum is a structured lattice, its energy is not inaccessible. It is part of the system's configuration. Unified dynamics provides the blueprint for interacting with this lattice. It proves that energy packets form exactly when processing debt reaches the 7768 threshold. Engineering the substrate involves artificially organizing the phase execution velocity of the network. High-intensity mode-locked lasers could theoretically target specific nodes. By flooding these intersections with extreme phase data, we can force the nodes past their capacity, deliberately creating new energy defects in the substrate. If energy can be extracted directly from the vacuum at any point in space, propulsion no longer depends on carrying fuel. This would bypass the primary constraint of the Tsiolkovsky rocket equation, the need to carry the mass of your propellant with you from the launch pad. Unified dynamics reveals a universe that is not a smooth void, but a deterministic, capacity-limited state machine. By identifying these combinatorial limits, we move from observing the laws of physics to engineering the substrate that creates them.